And folks, hear us okay? All right, let's give it a second, and then we can get started. Hello, folks. Good morning. Hello, everyone. Just give us like a few minutes to get started. Just like doing some last minute fixes. Right. I think we can just get started. So I'm gonna share my screen quickly. All right. Yeah. So welcome everyone. So this is basically so this talk is really about introducing like the AMD Developer Challenge in 2025, like the inference sprint. So there's like been a collaboration between like some folks from the Kernel bot team on GPU mode, AMD, and then the Data Monsters team. So the TLDR of this competition is that so this is like our first like real round of like writing kernels after the practice round that we had with PNPP. And so here basically you're going to be authoring like different reasoning kernels, like specifically FP8 GEMM, MLA with rope, and a fused MOE kernel. Um, and the grand prize for this, like basically, if you get really close to speed of light, like you can win up to like 100K in prizes, and with a flight ticket to San Jose, with an awards ceremony with the AMD team and other folks on the team here. And we're basically hosting this entire thing like within the GPU mode server. So basically, the idea here was that like if you have your own like MI 300s, like that's great. Like you should use them. You should micro benchmark. But if you don't, we really tried to make like the kernel bot job submission platform like as seamless to use as possible. And basically, if you look at the dates here, there's going to be, again, like sort of three very important kernels. If you need to find their reference implementations, you can like go check this reference kernel repo here, and this will be merged, the code will be merged shortly. It's very similar to the way we had like previous competitions. So basically, the reference implementation is written in PyTorch. So this is basically like just a reference implementation that's meant to be purely functional. There's also going to be like a submission that we're going to produce, which is often going to be like a Triton implementation, which represents like the current like best performance. And then of course, like as all of our reference kernels have, like there's going to be like a whole bunch of like target input shapes and configurations. And so for the prize pool, like basically if you're first place, second place, or third place, based on an aggregate of your rank over the different like three kernel leaderboards, you can win up to 25K in prizes. And if you get fairly close to the roof line in any one of those kernels, like you'll be eligible for up to like 100K in prizes. Just like in terms of dates, like basically pre-registration started on April 9, and then the submission window like opens like effectively today. So this date is incorrect. So give us until 12 like so give us until noon today. So 12 p.m. on April 15. Actually, yeah. So 12, and then the submissions are going to basically keep happening until June 8th, and then different competitions will have like different submission windows. So make sure that you check those out. You can form teams of up to 3 people. You like, and then just make sure like anyone can use the leaderboard today. You can submit like anything, you can flex. But if you want to be eligible for prize money, please make sure you register here because we'll need this before we can like distribute anything. So yeah, I guess like basically the experience is effectively going to be very similar to the way like it already works here with the leaderboard. So you're going to come here and you're going to see a whole bunch of active leaderboards. Specifically here, like in Central, there's going to be like different like new leaderboards get added. For example, we just added like a test leaderboard for like an identity kernel, but like in a few hours, you should expect to see like the FP8 GEMM kernel show up here. And then at the various release dates, we're also going to have the fused MOE and the MLA, sorry, MOE and then the MLA kernels. So the experience is going to work like very similarly to the way you already made submissions before. So you're going to say like leaderboard submit benchmark. Let's say here it's going to be the AMD like identity kernel. And then like GPU, and then you say MI300, and then the leaderboard name, and it's going to be like AMD identity. So it's like a very similar experience to what we used before, and here we expect the cold starts to be on the order of like 5 to 10 seconds. You'll get a GitHub like workflow here that you can check in, and you can see like the status of your job, like along with like the artifact. So basically, like what was the like results that you got. So for example, if we go here, you can go in and see the run results and download them and study them, and you can see like if there's any issues with your job here. We also sort of took feedback, like basically a lot of people, while we do have a lot of people on the Discord and a lot of people really enjoy coming in to see like results like and submit directly in Discord, like a lot of people are asking us for like a CLI like experience. So we've been testing something in our server, like as a sort of like alpha release. But effectively, like here, maybe I'll just give like a live demo here. Let's open up Cursor.
Yeah, I can do that. It's actually working now.
Okay, wonderful. Yeah, so basically you no longer have to use our Discord channel, and you can just like make submissions like within like your favorite like text editor. So yeah, Matej, please go ahead.
Yeah, so how do I do this? Yeah, so present.
Yes, you want to present it. It's like the middle button.
The screen. Okay.
Right.
And I hope. Oh, did I stop it?
You did, yeah.
Yeah, so let me try again. Share screen. Losing to. So you should see my terminal now, I would say.
Mm-hmm.
And I hope it's going to work. So the CLI is written in Rust, and it's a really simple CLI that will basically, in the end, it supports registering or re-registering through GitHub and Discord, which currently, this is not like this. This is currently the feature that we have issues to make work, right? But except of that, you can now test it locally, and the submissions are not gonna be recorded, but they're gonna work. So how you can do it is just basically do submit and a path to a file which you want to run. So for example, now math.py is a file that I have, and these are the kernels that we currently have on the main bot. So let's see, we can do mathful, and let's do on T4, and let's do a test. And now it's gonna wait. It's gonna submit the solution to our bot, and that one is gonna evaluate it. All of them are supported. Like we support now benchmark. Yeah, here it is, and it's been run on. T4. What you can also do is also run a submit, which currently will be recorded under a temporary user because we're fixing authentication issue, but you can do it to submit to a leaderboard and it's going to be there. We promise we're going to mark the users to the correct one or allow you to resubmit afterwards. And now when this finishes, it's going to take a bit longer because it runs all the benchmarks. And when this finishes, we're going to see the submission on Discord, which I'll share afterwards. Yeah, here it is. So we see all the results. It's a JSON, so you can just view it in whatever editor you like. And I'll move this.
Yeah, so for what it's worth, like I've been using this like new feature a lot. Like basically, I'll just be like in my regular editor, like Cursor, and then with my terminal at the bottom, and then every time when I submit something, I submit it. So
yeah,
like I can keep changing my code while updating. It's just been like significantly more convenient for me than attaching files in Discord.
Yeah, and this is gonna show you the user is not gonna be linked to your Discord user because currently the authentication, as I said, is not working. But we're gonna support that, and you can also submit from the CLI, which is gonna make the developer experience a lot better, I think. We also have a few nice features that we would like to show you. One of them being a website. Many of you complained about, or not complained, well, we didn't really like the Discord way of showing things. So we now currently have a website, which I can show you. that was made by Ben and one other guy that has a name that I can't pronounce. If Mark could give him credit in chat, or that would be perfect.
So this is JXT and GX. So he was the initial person who also donated the websites to us. So like we're very grateful for him.
Yeah. So this is the website. It resides on the domain gpumode.com, and it's gonna be basically a central place for all of the stuff.
Maybe Matej, can you zoom in a lot?
Oh yeah, sure. Wait, this is not gonna get pretty, but you can see it now.
Mm-hmm.
And it's gonna reside on gpumode.com and gonna contain all of the info about leaderboards, which currently, if you want to, you can click on them, see a lot of the info, what's the reference implementation, what's the description, language, the best submissions, etc. So I hope this is going to make the developer experience a lot better as well. And also, you can visit the official GPU mode resources and lectures from this. And another thing we have added is thanks to Eric and GC92, we have a totally new interface of how to submit. And I'm not sharing Discord, I think, right?
You're just sharing your whole screen, actually.
Oh, I also.
It was working correctly.
Yeah, so if I share it now, you should see that we have a lot better. We have a messages that Eric actually has not tested now. That if you end up on a first, second, third place or whatever, you're gonna get a nice message. And also,
Matej, could you zoom in a bunch, please? Your font's
again, yeah. Sorry for this. Yeah, here. So if we submit now, and let's say we want to submit to Matmo and what GPU, let's say T4, you're gonna see a lot better UI that also actually works for GitHub runners, which will be supporting the AMD competition. And it's gonna be running on MI300s. The whole competition is specified to be run on MI300. And yeah, let's wait for this. So you can see the message is getting like progressively updated, and I've got a third place. I'm so good.
Nice.
And you're gonna get a nice thread which will show you all the info before, and it's not gonna make the submissions channel this ugly as it was doing before. And
so as part of this for us, like we're sort of like playing around with like different like achievements or like things to give people that like win competitions. So if you have like any feedback for us what to do here, like let us know. I see one question from the chat from Veranchi is like debugging in MI300 on the server possible. Okay, so the main challenge here is that like it's actually very, very challenging to have a competition, like let's say with a few hundred people, where we distribute SSH keys like very broadly. Just because we want to know how people are using them wisely or not. And so we're mostly relying on a job queuing platform with Kernel bot, and you can effectively run as many jobs as you want, and we won't rate limit you. Like just do whatever you need to sort of debug things interactively with like this like 5-second lag. If you still like, I will say there's like one caveat to this, which is if you're doing really excellent work, like basically you're very prolific in the server, your kernels are very good, and you basically would really like to have a like full SSH access to a machine for this competition and other projects. Please tag Powderlove on the channel. So that's Anush, who's very popular on Twitter as well, and he can like help you get set up. But like fundamentally, I think for us, we're mostly relying on a queue platform where the assumption is if the cold start times is short enough, that's fine.
Yeah,
all right, Alex, hello.
Yeah, I think this wraps it regarding the infrastructure. Like as you've seen, the infra is not in the best state because debugging it is really difficult. But we're gonna ship updates hopefully really fast, and we'll have something done really soon. And Alex is here to talk about the kernels, which you're probably most interested about, and about the competition as a whole.
Yeah. So I think for those of you that aren't maybe aware of what the kernels are, they're public now, or roughly like what the problems are. But this competition will consist of 3 kernels, all of which at the moment will be for single device. So you're not going to have to worry about dealing with distributed comms or like that kind of stuff. But they're all kernels related to DeepSeek's or DeepSeek v2 or v3. So the main ones, the first kernel that you're going to be doing is the FP8 Blockwise GEMM, or I guess it's actually just a matmul. And so the details for this will be released very shortly, like all of the details about it. So like we will have a very nice problem write-up, both in code, like a PyTorch reference, and also with some math, if that's what you prefer, and maybe some diagrams and stuff too. And that will be running for the first roughly 2 weeks. So originally we actually had it where we would open the first kernel and then we would close it and open the second kernel. But we talked about it, and I think we actually decided that we're going to let people work on the specific GPU kernels throughout the entire competition, but they're going to be staggered releases. So the first 2 weeks are roughly going to be dedicated to the FP8 Blockwise GEMM. The second week is going to be the MOE kernel, if I'm not mistaken. It's going to be a fused MOE kernel. And the last week is going to be the multi-head latent attention. So there will be more details about these as we get closer. We don't want to release too much, obviously, because we want to give people time to focus specifically on the kernels that are active for the week. And so you also don't have to like context switch a lot between different kernels. But specifically, actually, you might have some questions about what multi-head latent attention with rope will actually look like, because there's some finicky things with like the KV cache and like how you're actually going to deal with this. So we're not going to release this information yet, but as we get closer, you will see this more. And so all information, just like the previous competition, all the relevant shapes of the distribution that the data is drawn from for all of these kernels is going to be public. So you can tune your kernels specifically for the shapes that we kind of care about. I think the way that we're scoring our runtime right now too is a geo mean of all of the test cases, which is slightly different than what we had before. It might make the weighting a little bit better as well. And yeah, I think that covers most of the high level stuff for this competition. Maybe I can leave a little bit of time for questions before I talk more about the FP8 GEMM, which is what you guys are going to be working on first.
Yeah, so just to reiterate, like basically you can sort of expect like most of updates of like when the next kernel to be released. Like you can go to the AMD competition channel we have on the server for updates. The gpumode.com website that like Matei showed also will have like details on the kernel. Like I think Ben was working on MathJax support if we need to allow the reference kernel, the input distribution, like pretty much everything. Thankfully, this time seeds are now private. So basically those are now stored in our database, so you can no longer seed hack your way. But if you find another hack, please let us know. So yeah, without further ado, yeah, Alex, please go into the math stuff.
Yeah, a small thing actually. Sorry to jump into it. We've got a message from one of our friends at AMD and saying that if you will need GPUs to debug stuff or anything, just let us know and we'll try to provide you some. So yeah.
So there's 2 ways I can go about this. I can either just talk about what the FP8 GEMM is going to look like, or I can share my screen and we can look at the official kind of problem description for it. I don't know.
Maybe let's do the screen share. I think it'll be more valuable.
Okay.
It's in the middle. There's like a present button with like with a addition symbol.
I see. Here, let me open this. That. Too many tabs. Okay. Share screen. Here we go. Okay. Is everyone able to see this?
Yes.
Okay. Unfortunately, it's on Notion. We're going to move it. Don't worry. We're actually probably, this is why Ben is working on the math check stuff. This is all going to be on the GP mode website. But yeah, this is kind of a work in progress thing. So a lot going on here. I don't want to scare people too much with all of this, but it's actually very, very simple, at least for the first problem. So the general idea here is, I think, maybe some of you are already familiar. In most kind of deep learning applications now, people, when they train their models, they like to train things in lower precisions. There are a lot of benefits for this. I think some of the more obvious ones are you store less memory, and you can take advantage of the faster tensor core instructions for smaller data types. So I think it's relatively well known that like float 8 is kind of considered the edge of like what people now call quantization, and just like what is considered low precision training. So DeepSeek, for example, chose to do a lot of their operations as weight 8, activation 8, which basically means you quantize both the weights and the activations to 8-bit instead of doing some weird like extra tricks. There are lots of things you can do here. But this is one of the more, I guess, simple ways to do this. So the name of this kernel is FP8 GEMM, but it's actually not really a GEMM. It's more of just a matrix multiplication. So this is actually the kernel that's implemented in DeepGEMM, which is one of the 5 libraries that DeepSeek open sourced a few months or maybe a few weeks back. I don't actually remember. And so this problem is actually very similar to what is already implemented in that library, but obviously that library is specific to CUDA. So the general idea here is you're going to be given 2 matrices, which is your A and your B, which you're going to multiply. You're also going to be given 2 scaling factors, and I'll talk about that a little bit because it's not super clear what exactly this means. But these are also tensors, and the reason these are tensors is so these dequantization factors are going to be in FP32, and your low precision matrices are going to be in FP8. The dequantization factors actually get applied to, like, it's one scalar for every like 128 by 128 block, at least for the B matrix. And so this ends up looking like this kind of weird tensor that gets like broadcasted out and multiplied onto your matrices. We have an image below that might make this easier to understand. We also will provide you a C matrix, which is basically just the output matrix that you can write to. So you're not going to have to like allocate any extra memory for any of this problem. The other guarantee is that all of the input tensors that are provided will start on device HBM. So you won't have to deal with the CPU for any of these things. We also are being a little bit nice here, where the shapes and everything all kind of divide out nicely. So you're not going to have to consider weird edge cases with like odd sized shapes or like unpleasant kind of casework. So don't worry about that. Again, all the shapes are going to be public. So yeah. And specifically also the input tensors are going to be E4M3, which for people that don't know, it just is which bits get assigned for exponents and which bits get assigned for dealing with fractions. Also similar to the DeepSeek library, everything except for the output matrix is going to be assumed to be stored in column major order. This is like the NT format, I guess, that maybe some of you are familiar with, but just to like be explicit here, like the A matrix will be m by k and the B matrix will be n by k, and those are both column majors. So, but when you multiply them, you obviously have to transpose the B matrix. So the B matrix is actually in kind of a convenient order. But generally, the reason why we do this is when you write your matmul, you're going to do some kind of tiling, and you're probably going to tile over, or you're going to loop over the k dimension. And so you want everything to be contiguous in a nice way. And it turns out this is kind of the nice ordering to do it. I think we're going to keep it this way also because this is how these are the specifications that DeepGem have. If for whatever reason people have issues with this, let us know. Like, we'd love to hear your feedback, but we're just kind of following what the standard is here. Are there any questions or? Okay, I will continue. So like I mentioned before, these scaling factors you can think of them as the dequantization factors. So normally what happens here when you're running your neural network and you're going to do this like FP8 GEMM, what's going to happen is like you start with your like FP16 or FP32 tensors, and then you're going to quantize it down. But obviously when you quantize it down, you're going to lose a lot of information. So usually people will store or like try to store some kind of like scaling factor that is like in less memory. So like it might be smaller and it might apply to say the whole matrix, or it might apply to like a part of the matrix. But this thing is going to be full precision and everything else is going to be low precision. So this is like a very similar thing. We just take out the part where you have to do this yourself. We're just going to provide you the constants that you're going to multiply out. Again, really simple. All you're doing is basically A times B transpose, and then also multiplied by the scaling factors. To make it clear where the scaling factors actually get applied, to make it easier for yourself, this is the diagram that you should look at. So basically, like the A scaling factor, which is alpha, and the B scaling factor, which is beta, get applied differently. So keep this in mind. This is how DeepSeek did it as well. But the A scaling factor, like let's say we take the first scalar in here, which is at 0, 0. This gets applied to the first 128 elements in a row in A. And so if you notice, every single element in the rows of alpha also map to an element in the rows of A, but they kind of map to multiple elements in the columns. And so this is like you can think of it as like alpha is just like a squished version of A along the column dimension, along the row dimension. But for the B matrix, it's maybe a little bit more intuitive. You basically just take out a 128 by 128 block, and that gets assigned one scalar value. And you kind of like tile this over the B matrix. Again, if this is unclear to anyone, please just ask now, because this is probably maybe the most confusing part about this setup, but everything else is like very, very intuitive. You're just writing a matmul in FP8 essentially. Perfect. Okay. As long as, we'll be happy to answer any questions people have about this during competitions as well. So don't worry, like, you don't need to be afraid of like hiding your solution or something. Like we'll be there to help if something is confusing. But yes, this is like kind of relatively standard for blockwise GEMMs, or low precision blockwise GEMMs. So, but this is just specifically what the setup looks like. And again, this diagram was made by Shekhar from AMD. So, thank you. I think it's a very clear and illustrative diagram of how to do this. But yeah. And so we also provide the code version of this. If this is easier for you to read, we also have this as our reference kernel. So don't worry, like it's not just on this document. But basically, like I said before, we initialize A and B as FP8. It's not clear here because PyTorch does everything in row major order, but these are actually going to be given to you in column major order. So the way that we do this is we initialize the transpose, and then we transpose it and we give it to you. So it's not contiguous in memory. Like it's not considered C contiguous. But it'll be a lot easier for you when you implement your kernel. And very simple, like we do this kind of, it's confusing, but this is basically just broadcasting the tiles, the scaling factors for the alpha, which is the left-hand side, beta for the right-hand side. And then we dequantize it first. So you should not dequantize it first. The reason we dequantize it first is it's easier in PyTorch because there's some like FP8 GEMM stuff is not always available. But when you implement it, it's obviously a lot faster to do the matrix multiplication and then apply the scaling factors. So this is just like, it's kind of an obvious thing to do, but just to make that explicit because the reference doesn't do this, but you should be doing the FP8 GEMM itself before doing the dequantization. So yeah, another thing here, the note about it being in column major order. Yes. So the last kind of thing that we provide to you here is the shapes that are going to be run during the competition. So these were selected by AMD for various reasons. They're going to be fixed, so they're not going to change, and they're going to be given to you, like, they're here. We also are, for this kernel and for the future kernels, we're going to give you a lot more information about like speed of light analysis. So like roughly, how far off you are from the theoretical optimal. And this is also related to the kind of the grand prize. I don't know if, Mark, did you talk about how that's scored or?
Yeah. So just concretely, folks, like the way we were conceiving of this was like as we're picking like basically the number 1, number 2, number 3 entry, the way it's going to work is like basically, are you the top ranking person? But just keep in mind that if your code is slower than our PyTorch baseline, you're going to get a score of 0. Because like, again, like I think Alex already hinted how poor, like we basically didn't write like particularly good baselines on purpose, just to sort of keep the meaning of the kernel as simple as possible. As far as the grand prize goes, the way this is likely going to work is that we're going to basically, you have 3 kernels, and we're going to look at how close you can get to the speed of light on an individual one. So the grand prize is going to be sort of parallel to the regular like competition of like the 3 kernels. So like if you're like the kind of person who just wants to hyper optimize like one thing and go for the 100K, we like strongly encourage you to do so.
Yeah. And then there was a question in the chat. Yes. So this code is not using it's not even doing an FP8 GEMM, actually, if you notice, and it's not using the tensor cores. So it's kind of the point. Like the reference is just there to give you a starting point, and it's a really bad starting point. But it's also a reference for checking correctness to make sure that your kernel, it should match up with this implementation. But yes, you should be, for the competition, you should be writing your own kernels that use whatever kind of like systolic array hardware units that are available on the AMD GPUs. And yes, this is actually, I think, the end of it, at least for this problem. So we're going to be providing this information for the other problems as well. I also want to be clear that FP8 GEMM will probably be the simplest kernel in this competition. Just because like it's basically an operator with some extra components that aren't like maybe you're not used to. But for some of the other kernels, you're also going to be given weights because they're model operators. And so you're going to have to load in the weights and compute some kind of operator over that. And so they might be a little bit longer, but the nice thing too is that they're probably even more unoptimized than some implementations of FP8 GEMM. So there's a lot of room for optimization there. But yeah.
All right. Any parting thoughts, or should we start concluding, folks? So, okay, maybe I'll start concluding. So just for context, folks, like registration is open until April 30th. So that's like about like 2 weeks left. keep in mind, you can still participate and submit your kernels, like you just won't be eligible for prizes unless you register. And since it's kind of like a big sum, and it's like high profile enough that like, we hope like this will be really worth your time. We, like our goal here was one, to make sure that the prize pool was like respectful of people's times, that like if you spend your time building something state of the art, that you get rewarded for it. And the other is that the kernels are actually commercially useful. Like the idea here is that like all the winners would be kernels that we would expect to be integrated in the vast majority of like inference libraries, so things like VLM, SGLang, like, and so we have like partnerships with a lot of like those teams, and so hopefully like this really makes this competition worth your time. Even if you don't think you can win, I would still encourage you to participate, because typically competitions sort of bring a lot of focus and you'll learn a lot. Concretely, if you want to sort of participate, and again, you don't need AMD GPUs to participate, go to our Discord channel, go to the AMD competition channel, and you can like get all the updates you need on how to submit, whether it's via Discord, whether it's our GitHub CLI. You'll get the latest updates on kernels being released, and it's also a discussion channel, so you can like use it to ask questions to us, the moderators, or like other people that are participating in the kernel. So yeah, again, remember that you can form teams of up to 3 people. So try not to do this by yourself. It's more fun with friends. And we hope you have fun with this. Like Matej was mentioning earlier, we'll have like a first set of like meaningful updates in a couple of hours today, just to make sure, and we'll basically be sure to share with people. Yeah, so like as far as the link goes, folks, it's just going to be the GPU mode. So there's no AMD Discord. It's just our Discord. So go to this Discord channel and like, again, look at the AMD competition channel and you'll find it. So yeah, if you have any questions, you can always tag the moderators or tag myself, Seraphim, on the Discord channel, and we're happy to answer any questions you might have. Okay, I think without further ado, maybe now's a good time to close on this, unless any parting thoughts, Matej, Alex, are we good?
Yeah, I hope you all enjoyed the competition, and we hope to see some cool kernels from all of you.
Yeah,
please. Yeah, good luck, folks, and make sure to have fun. See you again soon. Bye-bye.
Bye-bye.